Here is the first ever battery pack that you can charge check with a button, charge up with a USB, program with an Arduino, and drop straight in to power any of your projects. I'm going to go through how you can make this from start to finish. And to celebrate MakerVibe's recent monetization, I've got an absolutely massive present for you that I cannot wait to share at the end. So without any further ado, let's jump right in and build this thing. Rechargeable lithium batteries are amazing to use in DIY projects, but on their own they're sort of difficult to work with. There's a lot of different connectors, charging them is often quite an awkward thing to do, and on top of all of that, you basically have no idea when they're about to run out of charge. So to make something that fixes all of this, let's start off with the charger. There is an off-the-shelf module called the TP4056, which is great for single cell LiPos, but if you look at it carefully, it only has the battery in and power out pins. So we have no way of getting a charging status signal from this as is. And of course for us, that basically means that we need to make our own version. So we're gonna need the TP4056 IC, but in addition to that, we also need the 8205A and DW01 ICs for protection. And finally, we're going to need an IC to measure the battery's voltage in real time. And for that, I'm going to be using a MAX17048 module, which works over I2C and is designed specifically for single cell LiPos like the one we're going to be using. To tie everything together, we need a microcontroller, and I've chosen to go with the ATtiny1616 that I bought over from DigiKey. Okay, now that we know what components we're going to be using, the next step is to start connecting all of them together in a schematic, and I'm going to be using KiCad for this process. If you're wondering how I know where to connect everything, it's because the manufacturers of these components often tell you how they expect their products to be used in normal situations, so I'm literally just building those circuits out. And you also might be wondering why I'm not prototyping this on a breadboard first. And well, I actually did. I went through all the pain of creating these breakout boards to convert all the SMD components to through-hole, but unfortunately this project actually took me several months to make, and I've lost parts of the circuit along the way, so you're just gonna have to trust me when I say that it worked. Okay, going back to the schematic, there's two really important things that I want to point out. First, you can't upload code directly to the ATtiny. So I'm going to be using an Arduino Nano to act as the middle UPDI layer. And second, the ATtiny by itself has no serial output functionality. So to get it to output debugging messages, I'm using this FTDI board. For these reasons, I'm also planning on having the UPDI and FTDI pins exposed on the final product so we can program and debug even after finishing the build. I found the routing process for this board to be genuinely challenging, and the reason is because I wanted everything to have a small form factor, but at the same time, I'm also limited to making only 2-layer PCBs at home with my machinery. And honestly, I'm no professional at this myself by any means, so let me just do it and show you the end result. Okay, and here it is, ready to go. KiCad has this really good feature where you can visualize the 3D version of the circuit, and that's going to be especially helpful when we start building the enclosure for this. But of course, we first need to make this PCB in real life, so let's go ahead and do that next. The first step towards fabricating our PCB is to fix a 3D printed jig onto the CNC machine's bed, and after that you can attach the actual copper board onto the jig. Now the tool head needs to be positioned manually in the home position, and I like to set my home position as the bottom left hole. So I just keep moving the tool head down until it aligns as perfectly with the bottom left hole as I can, using just my eyeballs as a reference. Once we've found the home position, we need to create the height map by probing different parts of the board, and then we can start the top side copper milling process. After finishing the topside milling, we can take off the screws and turn the board over, make another height map and repeat the process to mill the backside copper. And of course the final step is to drill all the holes with the right sized drill bits, and finish up by cutting out the board. With a little bit of hand sawing, you can remove the tabs connecting the PCB to the rest of the board. This is looking great. The alignment of the holes between the two sides of the PCB isn't perfect, but honestly it's good enough for our purposes. Alright, and now let's go ahead and solder this thing up. I also went ahead and created an LED board and a USB receptacle board using the exact same techniques I've just shown you. And here is the final PCB with everything connected. It seems to be working great, so now let's build an enclosure for it. Here's the final 3D model in Rhino. After I got everything to fit together, I decided to export everything to Maya and do some basic product visualization. This rendering is okay, but it's kind of looking a little bit plain. So I decided to go ahead and design some stickers in Adobe Illustrator, put them over the geometry in Maya and try a few more renders. And I think this color scheme is looking pretty nice. And you know, seeing ideas like this battery pack evolve from a breadboard concept all the way to an almost finished product is really the most thrilling part of being a maker. But none of this is possible without understanding all the technical math, physics, programming, and electronics that's going on under the hood. And that is why I am super excited to present this video's sponsor, Brilliant. Brilliant helps you excel in math and computer science with visual, interactive problem solving and personalized practice. Brilliant's whole system is designed to be super effective because you learn by actively solving problems. Research shows that this way is far more effective than simply watching lectures or videos. It's a really good balance of interactive challenges and motivation, so you get to keep moving forward while also building a real understanding beyond the surface level knowledge. Brilliant adapts to you as you go along. It starts you at the right level, adjusts the practice based on how you're progressing, and helps you move forward at a pace that makes sense for you. The courses are designed by an award-winning team of teachers, researchers, and professionals from places like MIT, Harvard, Stanford, and more. The idea behind Brilliant is that everyone can be good at math. It's usually the way it's taught that makes it feel difficult. So instead of memorizing formulas, you work directly with concepts until they click. This way you build intuition and problem-solving skills that are actually useful. To learn for free on Brilliant for a full 30 days, go to brilliant.org/makervibe, scan the QR code on screen, or click on the link in the description. Brilliant has also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. As always, thank you Brilliant for sponsoring this video. Alright everybody, we have now arrived at the final stage of our build. But before we get to that, let's head outside to the cold, wintry world and paint our 3D prints to make the colors look a little bit more intentional. I'm using a black spray paint for the parts I want in black, and for the grey parts I'm using an airbrush. Alright, these printed parts are looking much nicer now, so let's head back inside and start building. And there you have it. Our very own battery pack is ready to go. To get different voltage outputs, I created these little docking stations, and underneath each one I have a fixed value boost regulator that I bought off the shelf, and that basically transforms the voltage to some commonly used levels. And don't worry, I haven't forgotten. I know I promised at the beginning that I've got a massive surprise for you, and I'm making this entire project completely open source, and it's available right now on the URL shown on screen. So head over there to get all the Arduino code, KiCad circuit schematics, and 3D models so you can really take this whole project and make it your own. Alright everybody, that's going to do it for this video. Thank you very much for watching. And I also wanted to take a quick moment to thank you for your support in helping MakerVibe get monetized. Honestly, it means so much to me, and it really would not have been possible without the help and support of each and every one of you. So thank you very, very much. Happy holidays, and I'll catch you in 2026.